Hey,
It's all live now. Okay, cool. Good morning, good afternoon, good evening. Welcome to a very special edition of Ask an OpenShift Admin. I am joined by some fellow Red Hatters today. I'm technically not supposed to be here. I'm supposed to be at a doctor's appointment, but they canceled on me all morning. So at some point in time, I'm going to get a phone call and I'm going to disappear. So, Andrew, what do we got cooking today, buddy?
yeah. Yeah. Well, good morning or good afternoon, everyone. Apologies for the technical difficulties. It turns out that Andrew's still learning how this works, and with Chris maybe not being here the whole time, I figured I should be in the driver's seat. So, apologies
Mm-hmm.
for that upfront technical issues.
It's probably my
So
fault, but yeah, go ahead.
no, not at all. So yes, thank you, everyone. Welcome to this week's stream of Ask an OpenShift Administrator. So this is one of our office hours series of live streams, which means that we are here for you. We are here to answer your questions, to talk about, chat about whatever it is that is top of mind for what you have going on inside of your environment. So this week, I am very happy to be joined by one of my peers, one of Chris's peers, Reese
Mm-hmm.
Oxenham, as well as on the product management team, one of our peers, and Ramon. I'm not going to try your last name because I know I'm going to butcher it, and I don't want to embarrass myself.
It's acido. It's kind of easy.
Okay, Asido.
Yeah.
Uh, so we are joined by Reese and Ramon in order to talk about bare metal installs. And not just any bare metal installs, because we've kind of talked about bare metal as an installation method, right? The non-integrated. But what we haven't talked about before is bare metal installer provision infrastructure, which is what we want to focus on today. Reese, I'll let you introduce yourself, and then Ramon, if you don't mind following.
Yeah, of course. Good morning, good afternoon, good evening, folks. My name is Reese Oxenham. I am the director of what we call the field product management team. So we work very closely with lots of customers and partners worldwide to help them be successful with some of our technologies. Me and my team, we work very closely on all things core platforms related. So we do a lot of work around bare metal installations, networking, storage integrations, and virtualization and those sorts of things.
And hi everyone, Ramon Acido Rodriguez, and I'm the product manager for OpenShift on bare metal, which involves many things, but essentially what we're doing is trying to make bare metal behave as a cloud provider, trying to automate, as we probably will discuss today, all the bare metal provisioning and management as if you were dealing with any other public or private cloud provider.
Yeah, so I know we have a bunch of exciting and interesting things planned, not the least of which, thank you very much, Reese, is a demo of what all of this looks like. And I know I want to talk about, OpenShift, bare metal, the when, the why, and all of that other stuff. But I'm going to hold off on that because, as is sort of our tradition with the OpenShift admin, Ask an OpenShift admin hour, is our top of mind topics. So if you're new to the stream, this is essentially a set of things that I think Chris and I think are interesting to you, things that have happened in the last week or two since the previous stream that might be relevant. So the first thing that I want to talk about, as soon as I find my notes list here, is VMworld is this week. So if you are, so I believe VMworld is free, the generic pass. Anybody can go and join. There is a Tech Plus pass, which I think you have to pay for. But anybody can go and join VMworld. You can look at all the sessions that they have going on there. And importantly, I want to share the OpenShift centric.
I already did. See, I'm in the doc too today.
Yeah.
It's amazing what happens.
So I'm going to quickly share my screen then, so you all can see what I see. So if you go to the link that Chris just very helpfully pasted in there, you'll end up at this page. And shameless self-promotion, one of these sessions has me in it. So down here in this integration considerations for OpenShift and VMware. So we did a panel session along with some of our IBM peers and VMware peers. So Dean Lewis down here does a great blog. I think I've mentioned his blog before. He published about doing vRealize integration or vRealize automation integration with OpenShift. So if you happen to have a few minutes, if you want to put that on in the background and listen to the various sessions, there's a ton of information that's coming out of there this week.
Mm-hmm.
So the second thing I wanted to talk about is, of course, KubeCon. I hope that nobody is surprised to realize that KubeCon is next week. I say that because I was surprised to realize that KubeCon is next week. It has snuck up on me, and it's not like we're busy or anything.
No.
But the good news is Red Hat, as you would expect, has a pretty substantial presence there, not the least of which includes Mr. Shorts.
Yes, I will be running around like a madman as usual. No, actually, I will be there for a lot of Day Zero events. I think I'm participating in 3 right now. That's my cap. And then I will also be hosting the Cloud Native TV wrap-up show on Day Zero as well, that Tuesday next week.
Yeah, I know for our team, basically everything has been getting dumped on Christian Hernandez because he's local, and so everybody knows that he's going to be there. So it's, Christian will be there. Christian, I need you to take care of this.
Yeah, I've been trying to help him, and I just feel bad.
Yeah. So I see that Chris posted into the chat here the link to our Red Hat landing page for KubeCon. So if you browse through here, and you can see that this is a very big, very in-depth listing of everything that we have going on at KubeCon next week. As a result of this, I will also remind you that we won't be streaming next week. Or at least I know we will be streaming other things, but this show will not be streaming next week. So take that time. I would highly recommend that folks invest that time into listening to what's going on at KubeCon. Remember, OpenShift is Kubernetes, and the things that happen in Kubernetes eventually happen in OpenShift as well. So as we highlighted during the last stream with the Kubernetes API deprecations.
Yes, which I have a shortcode. Ta-da.
Oh, thank you.
No problem.
Oh yeah. Oh, I forgot that there was I should really remember these things. It's not like I haven't supported like a dozen commons.
This is one
gatherings.
of the 3. I should probably mention the 3 I'm involved with. So obviously OpenShift Commons, I will be around that, and I think we're intending to live stream it. It's very weird. Things are hard this year. I'll just leave it at that. It's logistics and it's LA. So yeah. I will also be part of GitOpsCon, which is happening on this day as well. But it's like, I think, the Commons is in the morning, whole day event, where GitOpsCon is like a half day event. And there's a lot of other events that we're part of as well, like supply chain, PromCon. I think we're part of.
Well, I know Christian is intimately involved with the GitOpsCon, so I expect a sponsorship check any day now for promoting the GitOpsCon.
He's doing the keynote. I forgot about that.
Yeah. It's going to be interesting.
So yes, tons and tons of stuff going on with KubeCon next week. Again, definitely check out all the stuff that's going on there, not just related to Red Hat, but related to Kubernetes in general. There was another thing that I wanted to bring up. Oh, tomorrow. Tomorrow is the OpenShift 4.9 What's New live stream.
Yes.
So
I got it.
Thank you. So as you can probably predict, that means that 4.9 is not too far away, and we will be talking about, by we, I mean the product management team, will be spending time talking about all of the new features that are coming in with that. So we'll be live streamed here tomorrow, both across YouTube as well as Twitch. I know I will be here helping to answer questions, helping to shuttle questions back and forth to the product management team. So please don't hesitate to, if you're watching, to ask questions on whatever platform you're on. We'll make sure to get those answered as best as we possibly can. Yeah. And I know 4.9, 10, 11 seem to be busier releases. I know at least in my world, so I was on a meeting at 7 a.m. this morning talking about stuff that's happening in 4.10 and 4.11. So there's a lot going on, and these sessions are really, really helpful for keeping an eye on that. Oh yes, our Hope 9. Yeah, we did do an Astra presentation last week. So that was a fun one, working with the NetApp guys.
Yeah, so the Kubernetes deprecations are a 122 thing, and more are coming. So they will come into OpenShift as we update Kubernetes under the hood.
Yeah, and I actually, so in that same vein, I deployed my usual cluster this morning, and it turns out that I don't have anything in here that will break it. But what you'll start seeing is I think it starts with 4.8.13. Maybe it's 4.8.14. But you'll start seeing a banner in here that says that it's not eligible to update to 4.9 because of certain APIs being in use. So I do know, and because there's now, I think, daily emails that go to the product management team like, hey, these operators still need this work done for 4.9 compatibility. So I know everybody is working very, very diligently in order to make that as seamless as possible. So the last thing that I had to talk about today, and it is very serendipitous that Reese is here, is the poison pill operator. So I happened to see this morning, the docs team made an announcement that they have completed documenting a feature that was released with 4.8, but was basically unknown. So the poison pill operator is effectively a way of determining that a node is no longer accessible and then taking action based off of that. So Reese, I'm gonna let you kind of take over and talk about that, because I know you're very familiar with it.
Yeah, sure, not a problem. So I just want to back up a little bit and talk about why these things exist. So typically, if you're running applications on top of a Kubernetes or OpenShift cluster, you may run certain types of applications that you need to invoke some kind of remediation. If, for example, the host or the node that was running that application goes away. By go away, I mean it crashes, someone pulls the power out the back, or someone takes a network cable out or something like that. And Kubernetes will typically mark that node after a certain amount of time as not ready. It's not heard from it for a little while. But in some cases, some applications, they might have reliance on, for example, a storage volume. And you need some kind of external remediation to take place to recover that workload. Now, for a long amount of time, you as a Kubernetes administrator could go in there and you could recover that workload. By deleting the node, it will essentially tell the Kubernetes cluster, you can relocate this workload on another surviving node. And over time, we've added in additional automated remediation methods. Now, if you are using bare metal IPI, so our integration, which the topic of this conversation will center around, there was what we call an external remediation capability. What that would do is it would monitor all of your nodes, and if one of them went offline for a certain amount of time, which was configurable, it would essentially fence that machine. It would connect out to the out-of-band management machine, be that ILO, DRAC, or whatever it might be, and it would forcefully reboot that machine. What that would mean, what that would lead to is a guaranteed safe relocation of that workload, because we know that that machine has been turned off. This is akin to traditional high availability concepts. Stone this, shoot the node in the head to recover it. Now, this gave a predictable and rapid recovery of workloads on bare metal clusters. Now, what we are driving towards with the poison pill operator is kind of an evolution of that, where it can be run on any type of cluster. It doesn't need to have any external, access to, any out-of-band management platforms, any APIs. It doesn't have to connect into anything to forcefully reboot a machine. It comes down to the simple premise that in a failure scenario, one of two things has typically happened. So the first one poison pill tries to consider is, well, if this machine has had its power taken out of it, or the data center has caught fire, or it's just simply no longer accessible, there's a good chance that it's gone and it's not going to come back. Let's say, for example, the machine is actually still running. It's just not contactable. The poison pill steps in and it self-fences itself. It turns itself off. So in both of those situations, the rest of the surviving nodes know that either it's definitely gone or it has made sure itself is gone. And that's why it's called a poison pill. Essentially, that node is taking the poison pill and sacrificing itself for the good of the rest of the cluster. So this poison pill operator, forgive me, I can't remember exactly when it is. I think we had some delays on making this available because it was a packaging of the operator and putting the operator into OLM. But this is, as I said, something you can deploy on top of your cluster, requiring no external integrations. It can be run on any type of cluster, and it's very, very simple to set up.
And I want to point out that this is particularly, I won't say important, but relevant if you're using persistent volumes. Because if a node goes down, if it's marked unreachable, if there's PVCs attached, those don't get released. So it'll hold up rescheduling those pods. So the poison pill basically gives you a way of forcefully removing all of that and allowing all that workload to be rescheduled.
Correct. And that's what I was saying. As an administrator, before we had these remediation capabilities, you would run into that situation where, to your point, the pod that was holding on to that persistent volume claim, that would block it from the Kubernetes scheduler from moving that workload to another machine and reassigning that PVC. So you as an administrator, you could go in there and you could delete the node. And by deleting the reference to deleting the node object, you're essentially telling the Kubernetes cluster that I have taken manual action. I know that that machine has gone away. I know it's safe for that workload to be rescheduled. Now, Kubernetes will go ahead and do that. It's it's assuming you've taken that action. Otherwise you might end up with some data corruption or data consistency problems. But it's assuming that that action has taken place. With both the external remediation that we can do with bare metal IPI and the metal cube integration or poison pill, it takes care of both of those. So it's making sure that the machine has gone away, but then going the further step of deleting the node automatically, so that the scheduler can reschedule those workloads.
And RHope 9, I see your question. Will the poison pill operator be able to communicate with the Vsphere API? So no, because it relies on the other functions of OpenShift. So when Reese says it deletes the node, it literally just uses machine operator, machine API, and deletes the node, and then relies on the machine set to create a new one. So it doesn't have to do any direct integration. So,
sorry, just one more thing. It deletes the node, but it's assuming that machine, or in the VMware example, that machine is going to reboot. It will reboot and it will re-register itself when the kubelet comes up. So it doesn't even need to do anything with the machine set. That machine set, the number will actually stay as it was. All we're doing is telling Kubernetes that machine has definitely gone away. It can reschedule the workloads. Then after a few minutes, if it's bare metal, it might take longer. If it's a VM, it'll be a little bit quicker. But that machine will re-register itself inside of the cluster, and then pods can rebalance themselves as and when required.
That's a good point. I think it's the machine health check is the one that will remove the node, whereas poison pill just removes it and reboots it and then lets it come back.
Right.
So you touched on a couple of things inside of there, Reese, that are tangential to what we are talking about today, or not really tangential, but they are very relevant to what we are talking about today. So bare metal is, and I want to start by saying that, well, first I want to start by acknowledging Ben joined us. So
hey, Ben.
Sorry for taking a while to get to you, Ben.
No, that's fine. I was running late, just had a customer call.
Yeah, no worries. So first, Ben, if you don't mind introducing yourself for all the folks who are watching.
Sure. My name is Benjamin Schmaus, and I'm a product manager here at Red Hat, and specifically on things like bare metal. So that's kind of why I joined today.
Yeah, and Ben is one of those super smart technical people that I use as an escalation point. So just remember, between the three folks who have joined us today, like Andrew knows nothing. All the hard questions get passed along. So, So the first thing that I want to highlight is, from Andrew's perspective, we overload the term bare metal. We use bare metal to refer to both an installation platform, i.e. physical servers, as well as an installation method, which is now, I think we've gotten better about it in the docs, but it is now the platform agnostic or install to any platform mechanism. So I avoid the term bare metal UPI, even though I know quite a few folks use that, because UPI still implies that there is a cloud provider involved. Bare metal IPI, there absolutely is a cloud provider involved. And I think that's surprising to some folks. So with that out of the way, I wanted to ask, Ramon, from your perspective, I want to cover kind of two things. So one, where does bare metal fit in? When should we be considering using a bare metal cluster or nodes that are deployed to physical servers? And then two, how does that work? I think you're one of the main product managers for things like the Metal Cubed project, which Reese just mentioned a moment ago. So kind of going from there.
Sure. So there are many reasons why we've been learning from customers. They want to have Kubernetes on bare metal. Reasons like you have workloads that require access to, say, a GPU, right? And it needs to be a GPU passed to the workload to do whatever they need to do. So this is direct access to the hardware. Sometimes they need to process large amounts of data through the network, and many servers these days come with SRIOB enabled NICs, right? And you do the same, but you need access to the hardware in order for your workloads to access this type of NICs. So these are two examples very directly related to running workloads directly on the hardware, right? With no layers in between. Then layers in between, well, when you have OpenShift Kubernetes on top of another platform, all of a sudden you have to manage two platforms, right? At least, plus the bare metal itself. And usually that's not a problem. In fact, many customers come from using, if you are on-prem, say OpenStack or AWS or any other public cloud provider as well. And then you start with Kubernetes, then you install OpenShift, and well, you all have made like a transition into this world through the multiple platforms that you are dealing with. But then you realize, hey, and this is direct feedback we have from large customers having to deal with very large scale clusters for different purposes, right? And they say, look, if I can get rid of one of the platforms that I need to manage, once I am only working with Kubernetes, working with OpenShift, then my life is going to be so much easier. So there's that incentive as well. On the other hand, which might seem contradictory, some customers have told me, look, I'm not in the business of managing hardware, right? I'm in the business of managing applications, and managing hardware, servers, network equipment of any kind is difficult, to say the least, many times, right? In comparison, perhaps not to everyone, but in comparison to managing software. So we need to provide solutions for these requirements, these reasons that different users have to use bare metal. And for example, using bare metal as a platform, which is what we do, using and managing, needs to help with the managing of the bare metal itself. Once you are working with OpenShift on bare metal, if we can help with managing this bare metal, and here is where what you mentioned before, Metal Cubed, comes in, or rather the bare metal operator that uses Metal Cubed, right, as the layer that manages the management of the different types of hardware. So with all of these, we provide a solution where the management of the hardware is probably less complex than if you did everything yourself, and do it yourself involves. I need a DHCP server, I need a Pixie server, I need to manage images to install and configure the operating systems. All of this is something that with bare metal API, we're taking care of, right? These are things that will alleviate a little the problem of having to manage the physical infrastructure. So,
and
yeah.
I want to point out that is just like we have a machine API provider for, say, Vsphere. Our Hope 9, you were just talking about that. I can, through the machine set mechanism, which uses machine API, basically say, hey, VMware, provision me a new virtual machine that I'm going to use for, whatever. We can do the same thing in this instance with physical servers.
That's right. Yeah, and that's the magic that we have with, thanks to Metal Cube, as I would say, the core technology behind this, and Metal Cube using another technology with years of experience in managing hardware, which is Ironic, that comes from the OpenStack project. And Ironic over the years has specialized in managing it. You may think it's simple, but it's a lot of operations, a lot of, say, polish that we've been doing to it over the years, so that in this business, in this case of managing hardware, we have got very, very, very good, I would say. So putting these two technologies together, wrapping them around with the bare metal operator, and using this on day one to do the installation over IPI, and on day two to do maintenance, regular maintenance of your hardware, has made this to behave as you were saying, VMware or any other cloud provider that uses the machine API. In fact, when you deploy with API, one of the things that we do is we deploy the machine API, and then the servers that are, the data structure is bare metal host. So this bare metal host in reality is a machine, which in turn is a node to the eyes of OpenShift, right? And the operations that you do in a node, they are translated into operations that end up being done in the physical node, right? Thanks to this operator. So maybe it looks simple, but there's a lot of magic, as I was. It's not magic, it's a lot of very smart engineers putting their brains on this, but yeah.
So I don't, Reese, I know, or I think you have a demo staged, and I don't know if you or Ben are able to answer. Like when you look at the bare metal install process, my favorite is usually to do like an OpenShift install explain. There's a lot of things that go into that. And that is effectively, and I giggle a little bit, Ramon, when you say, oh yeah, managing hardware is simple. Well, no, it's as a human managing one piece of hardware, it's relatively simple if time consuming. Hardware takes a long time to reboot compared to VMs.
And
but
you
when
typically have to touch it.
Yeah, but when we're talking about even ones, multiple servers, if not dozens or hundreds, it's not easy at all.
It's not easy at all, and we've had to put a lot into the OpenShift bare metal project and all the metal cubed integrations to kind of bridge that gap. I mean, realistically, if you look at some of the other platforms, be that a public cloud or be that on-prem virtualization, there is an API that we can call. We can say, hey, create me a virtual machine. It needs to have X amount of memory, disk, NIC layout, and it goes away and does it. It also abstracts all of the underlying infrastructure away. It's got all of the networking and storage, and it does all of that for us. So from an onboarding of a new virtualization or a new public cloud platform, it's relatively straightforward. I'm not going to say that our engineers that go and do all that integration, that their job is easy. I'm not saying that for 1 minute, but when we have to do this for bare metal, it becomes a little bit more of a challenge. Those so if you were a customer of OpenShift before we had done all of this bare metal integration work, yes, we had all of the capabilities to dynamically scale our infrastructure, make use or make reuse of underlying storage and networking efficiencies, and push that all the way through into the OpenShift layer. We wanted to provide a similar capability for bare metal, but there is no API for bare metal. I can't just call out to an arbitrary API somewhere and say, hey, give me a bare metal machine, and it has to have this config, and go and do that. And so that's where
the packet folks might disagree with you, or I guess they're Equinix metal now.
Yeah. Sure. Oh, yeah. Right. But
I would say, yeah, and one of the differences is that say that you are AWS, somebody's managing all this hardware somewhere, right? Probably thousands of engineers, but it's hardware that they know, it's hardware that they are familiar with, it's hardware that needs to comply with a series of automations that they've put in through the years. But in what we are doing, we need to deal with customer XYZ type of hardware, and that can be, it's usually common hardware, right? Well, not all the time, but usually it's hardware that you would know. But it's hardware that each of them has different tweaks, different areas that you need to look after so that you can manage them in a standardized way. So this is what we've done. And with Metal Cubed and the integration in it of Ironic has drivers for iDRAC for Dell, for ILO in HPE, for IRMC in Fujitsu, for you name it, Redfish especially. We probably need to talk a little bit about Redfish, which is a standard, say, not implementation, but a specification of how to manage hardware through APIs. Redfish, in fact, is helping us a lot. It's not perfect just yet. Its implementation, at least, is not perfect, but it has helped us a lot to treat hardware in a very, very similar way, regardless of which vendor you have chosen, right? But all of this to say that all these difficulties in managing different types of hardware, which can be anything that your customer may have, they are solved to a degree, right? We work on this every day thanks to this technology, right? You give us a Dell node, we know how to manage it. You give us an HP node, we know how to manage that, right?
I can tell you it's light years better than what I used to do, which was using a serial concentrator, telnet in, and then access the serial console for Sun and then Oracle servers. And it was absolutely miserable to try and automate and get that stuff done compared to, you know, the pretty impressive and amazing things that we have available today.
It's true. And by the time you have automated something for this specific infrastructure or piece of hardware, you get something new and you need to change the scripts, the way you address the BMCs if they have, etc. So having this abstraction layer, and with the years of experience that we have in this abstraction layer, has been key for us to be able to publish and release all this software for managing bare metal so quickly.
So, Reese, I want to give you a moment to kind of stage the demo that you wanted to show and show us what all of that looks like. And while you're doing that, sharing screens and everything, I'm going to answer, apologies for butchering names, Bashesh's question here. So Bashesh asks, in simple terms, Kubernetes is simpler than OpenShift, but what points would you use to convince a customer to migrate to OpenShift from Kubernetes? And I think we all, you know, have different opinions or different perspectives on that. I will say when Andrew answers that question, I usually break it down to two things. So one is test and integration, and most importantly, support of all of the components that make up OpenShift. So OpenShift is Kubernetes. It has a creamy Kubernetes center at the, you know, that is the foundation. And then we build upon, right, we add on a bunch of value to that. So think CoreOS, you know, Red Hat Enterprise Linux CoreOS, the machine config operator, and all the things to manage that underlying operating system. You know, a registry, the admin GUI, right? All of that stuff that makes OpenShift and not just Kubernetes. And importantly, taking all of that and testing it together, making sure that it's all going to work together, making sure that, you know, when you upgrade from version to version, you have, I'm not going to say a perfect, you know, 100% chance of it always working every time, but a very, very, very good chance that it will. And if it doesn't, you can pick up the phone and you can call somebody. So the other one of those is usually, you know, kind of related to all of that, which is to really, you know, Red Hat's perspective is to go into production with Kubernetes. You need more than just Kubernetes. You know, you need things like lifecycle management of each one of those components to include the underlying operating system. And, you know, you need a logging solution, you need metric solution, you need all of those things, which, you know, OpenShift's goal is to provide all of that. So I saw Chris dropped out. He waved goodbye. So thank you for joining us, Chris. We'll see you next time. So with that, I don't know if you all have anything to add to my slight diatribe there. You're more than welcome to, or Reese, you're happy. I would love to see what you've built.
Sure. Well, I would say Don't get too excited about what I've built, but we'll certainly.
I have seen many of your demos, and I always get excited for them. You do a great job. So.
Oh, well, I appreciate that. So I'm assuming that everyone can see my screen, and that the text is big enough.
Yeah, please let us know if we need to make it any larger for anybody who's watching.
Sure. So what you will see, so this is a, I was going to say this is a bare metal cluster. This is a bare metal cluster. It just happens to be a virtualized bare metal cluster. So we follow the exact same workflows, but we just have some automation around essentially simulating bare metal clusters inside of our environment for demonstration purposes and testing out various different functionality. So everything you're going to see here, follows exactly the same code path as any real bare metal cluster does, but behind the scenes, I'm actually just using virtual machines for it. So the big thing you will notice is that on the left-hand side of the overview page, you'll see provider is bare metal. So this is utilizing all of the bare metal capabilities and the functionalities that Ramon was just explaining. So behind the scenes, we do have Metal Cubed providing us with, or providing OpenShift with an API to aggregate, control, and automate physical hardware. Now, one of the things you're going to see on the left-hand side if you go into compute is a new entry called bare metal hosts. And in here, it will show us all of the various different nodes that we have associated to our machine. So you have 3 masters and 2 workers inside of my environment. Now, in here you have, for example, a management address, because typically if you're going to do an automated bare metal installation with IPI, you need to provide some additional information to the installer so it knows how to go out there and power these machines on, set them to boot up. In this environment, I'm using more traditional IPMI with Pixie, but as Ramon was saying, there is possibilities to use Redfish as well. Now, what I will show you is the installation config. So this describes how the OpenShift installer or gives all of the configuration information to the OpenShift installer so that it can run. And there are a few very important details here. So first of all, if I go down to platform, it is bare metal. So we are specifically saying when you do this OpenShift installation, utilize the bare metal, which is, utilizes Metal Cubed behind the scenes to drive this installation. At the top, I've specified how many machines I want. So 3 masters, and at the top we got 2 workers. And then we have to specify all of the individual hosts. We have to tell it which machines to use. And so we have to specify BMC. This can, of course, as I said, be Redfish, but in my environment, I'm just using IPMI, a username, a password, and a unique identifier, which in this case is going to be its MAC address. So when these machines power up, they will attempt a DHCP, they'll Pixie boot, and they will be identified by their MAC address. We then say...
If you don't mind me interrupting you there. So
Sure.
It's possible for the installer to, I think it deploys a VM on that host, and then basically it'll host the DHCP and Pixie services you need to load those nodes initially.
Correct. So in a very similar way to how most IPI installations work, when you run OpenShift install, it provisions a bootstrap machine. Now this bootstrap machine will essentially help bootstrap the cluster, and then it will hand over control and responsibility to the resulting cluster at the end. But the way that we set this up is that bootstrap machine temporarily runs, as Ramon said, OpenStack Ironic behind the scenes, and that's what we use to automate the provisioning of the bare metal machines. So we spin up a really, really small OpenStack Ironic instance on top of that bootstrap VM. That goes ahead and starts the bootstrap process off. Pixie boots the machine. So as you said, it starts up a DHCP server there. It lays down the image, helps get the cluster running. Then that bootstrap machine steps back and lets the cluster itself continue the rest of the process. So that initial bootstrap process is really only responsible for the initial deployment of the masters. OpenStack Ironic then gets deployed. So I got a rogue cat here trying to push my screen around. The OpenStack Ironic will then get relaunched on the resulting cluster, it will then go ahead and deploy the additional workers, which is why on here you will see the 3 masters are considered externally provisioned because they were deployed by the Bootstrap VM, and these 2 workers are provisioned because this cluster has provisioned them in the latter part of the installation.
Which, to be clear, is how all IPI works, right?
Sure.
With the cloud providers, the installer, OpenShift install, is the one that provisions those resources into, AWS or Vsphere or wherever it happens to be. So there is no machine sets yet for control plane nodes.
Correct. And yeah, that's why you'll see, we have a machine set here just for the worker, and we just have 2 of 2.
So Reese, while I have you paused for a second, I'm going to rewind you slightly to the poison pill operator. Will it work with UPI and IPI, or is it IPI only?
It will work on any type of cluster. It could be UPI, IPI. Typically with bare metal, we have the external remediation through Metal Cubed. So you can set up a machine health check, which will monitor the machines. And then when it goes over a certain period of time, one of the other machines will contact this IPMI address of the failed node and will force it off. And so it can short circuit that remediation process. So this is really great if you want high availability. And one of the really good use cases for this is for running OpenShift virtualization, or CNV. Let's say, for example, you have a virtual machine and it's critical for whatever reason. There's one of it, and you need to know that that will get restarted very, very quickly. You essentially have 2 choices going forward. You have the external remediation if you're running bare metal, IPI. If you're using UPI, you now have another option with the poison pill, in that, again, going back to what I was saying earlier, either that machine has gone away, and it's definitely gone away, or it has consumed the poison pill. So in both of those circumstances, after a defined amount of time, you know that, again, it's either gone because it's caught fire, it's, power's gone, or it has consumed that poison pill, so it can relocate that VM.
Let's hope there's no fire.
No, indeed, absolutely right.
ZP, to quickly answer your question, how are entitlements calculated? So entitlements, you only need to entitle compute nodes where you're running your applications at. So control plane nodes, unless you have marked them schedulable and have your applications running there, you don't need to entitle them. Same thing with infra nodes. And I'm digging for the link for the subscription guide, as well as rhope9. Thank you for posting that link.
Okay, so I think I've pretty much shown everything I wanted to in this. It's very similar to any other IPI configuration, specifying the VIPs that you want to use. But the big change here is when you specify the hosts, you're actually telling it what to use and how to contact these things behind the scenes. Now, what you will find on a bare metal cluster is there is a pod in OpenShift Machine API, and this is where you have the Metal Cube pod. And so inside of here, this is where all of the cluster management, the bare metal management, actually happens. So inside here, you will find there are various different OpenStack Ironic pods, and these are the ones that actually manage, when OpenShift has to say, restart this machine again from a remediation perspective, or I want to add a new machine, it has to go via OpenStack Ironic to do it. And so we just provide this as an interface, essentially translating all of the well-known, well-loved OpenShift features into, give us the ability to do the same on bare metal as well. And just to prove that OpenStack is actually running behind the scenes, I've got an OpenStack Client pod here. And if I just, this is literally just a pod that's running on top of my OpenShift cluster that just has the OpenStack command line tools installed. And I've generated a config here. I just grab the password, which is just a secret, and it's always running on a very specific IP address, and I just paste it in the password there. I can do OpenStack bare metal node list, and you will see that all of my machines are actually just OpenStack Ironic instances.
I like that you're highlighting this because it's a reminder that this isn't net new. This isn't something that we just created. When was bare metal
No.
API 4.5, 4.6? It's not net. It's like a decade old at this point.
Yeah, exactly. And so we have a lot of experience in managing bare metal. We haven't reinvented the wheel here. We knew that we needed a component to handle the the basics, like turn the machine on and off, set it to Pixie boot, clean the instance so that they can be reused should we want to. And Ironic has all of these various different drivers, these interfaces, these features. It makes sense to reuse those capabilities. And Ironic here is standalone. It doesn't have any of the other OpenStack components. We just use it for the bare metal management piece. And so yeah, it's absolutely reuse of components, and it works really, really well for this use case.
Yeah, no big scary things like under clouds and over clouds, like you might be familiar with if you're a OpenStack customer.
No, indeed. So yeah, we have all of these. Obviously, power state is got over IPMI, and then that's exposed through Metal Cubed into the OpenShift UI. So if we go back down to bare metal hosts, and we were to say go on to, let's just pick our worker one, we have the power state here. We have various different information about it. It collects insights and information about it. It also gets additional information because we've inspected this machine before. We know all about its network interfaces. Its
So
disks.
wait, let me dig on this because I don't think I've ever noticed that there's a bare metal hosts item that gets added to the menu over there with bare metal API. So this is effectively like this gives us insight into the hardware that we're running on.
Absolutely. And again, the big driver behind this is to provide an equivalence, for customers that have experience in running on top of, any other infrastructure, with AWS, VMware, OpenStack. We can get that insights. We wanted to provide that same experience with bare metal, and that's really where Metal Cubed and the OpenShift IPI, it's really bridging that gap.
Yeah, this is it completes without even realizing it, right? At least for me, it completes the whole story of, with OpenShift, I manage the applications, I manage the Kubernetes, I manage the underlying operating system, and I manage the underlying nodes, kind of regardless of where those nodes are deployed at. That's super interesting.
So what I will show you is, well, let's say I've got this cluster now and I want to add more capacity to it. I want to add more nodes. Well, if you are using a typical provider, such as, again, Vsphere, AWS, OpenStack, or whatever it might be, you'd simply go in here, you'd edit your machines, and you would add another one, and it would automatically spawn that. Now, this works in exactly the same way inside of bare metal. However, if you look at my bare metal hosts, I'm using them all. They're all provisioned onto. So I have an additional machine that I want to add into this cluster. So what I have here is just a file with two resources, resource definitions. The first one is a secret, and this is essentially a username and password for the BMC of my node. And then I have a new bare metal host object. I give it a name. I give it the MAC address of that particular machine. I give it the IPMI. The credentials are pulled from this secret I've defined, and root device hints, again, just saying, hey, deploy on this disk, which of course is useful if you have real bare metal machines and they have 10 disks. You want to make sure deploy onto this disk. So what I'll do is I'll just OC apply BMH, and I need to put it into OpenShift machine API. So I now have defined this additional worker, and you'll see immediately in the UI, I have this additional machine. It's registering. So it is going to go ahead and it's going to attempt to contact that machine. It's going to populate it into OpenStack Ironic. Look, you can already see it's going into the inspecting mode. So it's going to power on this physical machine. It's going to collect information about it, and it will sit there waiting for us to consume it by increasing a machine set, or getting it ready to actually be used. Now, this obviously takes a few minutes to do. It is a VM behind the scenes, as I've explained earlier. We're kind of faking bare metal here just for convenience. But it would follow through the exact same process if this was real metal. So if I go back,
I assume that inspecting, is it querying the IPMI or the Redfish interface?
Correct. Yeah. If I go into my bare metal node list again, you'll see that we now have this worker 3. So it's populated inside of Ironic. It hasn't yet provisioned it, but it's powering on because its state is inspect wait. So we're just waiting for that machine to actually do something. Now, hopefully, let me see if I can bring that up here. Now this might not...
I forget that your workstation is a monster.
Yeah, I'm actually connecting to machines in the data center here, but it is a pretty good machine. Right, so this is my worker 3, the one I'm just provisioning. And so you'll see that it's booting up into the Ironic Python agent environment, at which point it will essentially get it ready so that it can be consumed. And it will stay there just essentially just waiting for us to use it. So if I check here now, it should be just probably okay. It's still inspecting. As I said, this might take a few minutes to do, but all I want to really do is show you us scaling this machine set and it eventually becoming part of that cluster.
So I'm looking through the questions here. rhope9, thank you for pointing out that you can get a developer subscription. So if you have a Red Hat developer account, that also entitles you to the same 16 cores of OpenShift that you would get with 16. I think you get 16 RHEL licenses and all that other stuff. I haven't checked recently. There was an issue on the back end when you were changing, if you log into the console and go to associate that developer license with your OpenShift cluster, there was an error with that. I haven't checked on that in the last few weeks. Hopefully they've got that remediated. I'll follow up on that. And then, Master Light was asking about using Fedora, because I guess they noticed that you're using Fedora, Reese. So I switch back and forth between Mac OS and Fedora, but there's a lot of folks in Red Hat who use Fedora, as well as what we call the RHEL CSB, the corporate standard build. So what you'll see is a lot of Red Hat folks, we run our own operating system, kind of consistently and frequently.
Yeah, I think I've been using Fedora since at least 2006, so it's just second nature to me to use Fedora. So it's yeah, and this is also on my own personal workstation.
Yeah, I have. So right now I'm on my Mac because that's where all of my streaming stuff is attached to. But right over here, I have a Fedora workstation that I use on at least 50% of the time. ZP asks, are there any additional CRDs that need to be installed, or is it out of the box support?
So you have to deploy bare metal IPI. So all of the resources you need are automatically deployed and configured when you select bare metal as the platform that you want to use as part of your installation config. You don't have to define any additional resource definitions to do this. I applied this BMH using the CLI, but you could just as easily go in here and use I could use the dialog, and it'll ask me the details. I could put the MAC address in and how I wanted to do it, and it'll you can do it via the UI. That's absolutely fine. But no, to do this, the platform has to have been deployed with bare metal IPI. You can't take a bare metal UPI environment and turn it into an IPI environment.
That sounds like some experimentation that Ben might have done at some point.
Potentially.
So I'll point out that, like with Vsphere UPI or Rev, or no, not Rev, or OpenStack, or basically all of the other UPIs except for Rev, when you install or you deploy a cluster, the cloud provider is still there. So if you do vSphere UPI, it's still the vSphere cloud provider. So after deployment, you can add in machine sets, and you can dynamically, scale nodes just like you would if it had been deployed with IPI. Rev, for reasons they that's not even a word. They decided to use platform equals none or a non-integrated install when doing their UPI. But bare metal UPI, and the reason why kind of up front I said bare metal UPI doesn't really exist because there is no cloud provider with bare metal UPI, and you can't mix
You
cloud
wouldn't get
providers.
any of this.
Yeah, so the reason why that's important is you can't mix cloud providers, and that's a Kubernetes limitation. So effectively, you could add a node. So let's say I have a non-integrated install on physical servers, right? No cloud provider equals none. And I wanted to add some nodes that have a cloud provider of bare metal. They would probably join the cluster, but then would be evicted after, I think it's no more than 5 minutes, and basically kicked out by the underlying mechanisms. So you can't mix those. It's an upstream Kubernetes thing. I've got the link around here somewhere because it comes up all the time.
Whilst you're doing that, Andrew, what I just wanted to do, because this might take a few minutes, I know we're running up against the clock here. Now that this machine has passed the inspection stage, it's going into an available state. So this is kind of sitting in a pool waiting for me to assign it. It's not in my nodes. I still have my 3 masters and 2 workers. What I'd need to do is go into my machine sets. I can scale this and say 3. And what that will now do is if I go into my bare metal nodes, it'll go into provisioning state. So at this point, it's going to write the CoreOS disk image to the physical disk, and it's going to reboot that machine, and it will join the cluster just like any other new node would. And I would dynamically scaled my environment with plenty more resource. If I look at this, it'll probably now show that it has an instance. It does, instance, and it is going to a deploying state. And again, we're literally using OpenStack Ironic to drive the deployment here because it has well mature ways of doing that. And we're literally just using a very small component of OpenStack to do this.
And just to reiterate, and I think you already said this, while those nodes are in that kind of waiting state, you can use that with the machine autoscaler and all of the other functionality.
Absolutely, you can, yeah.
LSI, how do you manage to always use the latest CoreOS Pixie image? So you don't with IPI. So with OpenShift and IPI, whether it's Rev IPI, Vsphere IPI, basically when you deploy the cluster, it'll upload a template virtual machine. Any new nodes, when they are created by machine sets, get created from that template. And the first thing that happens when it boots is it connects to machine config operator, and machine config operator says, go and download this new CoreOS image and lay it out. Yep. The same thing happens here. Basically, it boots up to CoreOS, it connects to machine config operator, it says, hey, go in, it's RPM OS tree, so go and apply this image, and it does exactly that. So the good news is with CoreOS, so long as you are on the current or older, that's the behavior. If you're on a newer version, it gets weird.
Yeah, so just to add to that, in the install config, I point to a very specific image that I want to use, and I only do that because I've got it cached. It's just to speed up the deployment process, but by default, it would just reach out to wherever the installer version, the manifest says to go download it. And to Andrew's point, that image will be essentially persisted by OpenStack Ironic, so it'll always deploy that CoreOS image for the life of the cluster. But again, when it comes up, it will be instructed to download the latest version that's available. So it'll only use that slightly older version for a little while, and it'll always be pushed up to the latest version.
Yep.
Very, very quickly.
Yeah, almost right away.
Hey,
So go ahead, Ben.
Can we back up to that install config just so you can clarify? So you mentioned that you've got it set up because you're doing it for caching purposes, but customers that were using this in a disconnected environment also would have a similar string in there to point to their local cached copy of the Arcos image, correct?
Correct. Absolutely correct. Yep.
Actually, you bring up something really important, Ben, and we just got asked this earlier this week. Bare metal IPI, like all of the other installs, works disconnected too. Absolutely.
Yep.
Yes.
Yep, it does. I don't think
So does this function, is this a part of like the zero touch provisioning stuff that we're starting to see come with ACM? Is all of that related?
It is to a degree, because zero-touch provisioning uses API to deploy the initial cluster, and then obviously the problem that it solves is very specific, right? It's provisioning without any touch, I guess. That's what we're calling it, zero-touch provisioning. But it streamlines the whole workflow from deploying your first cluster that will be your cluster, say hub cluster, right, of clusters that will help you to deploy the rest of the nodes with ZTP. So it's all related in reality.
And then one last question that I hope doesn't get me in trouble. Do we have any intention of being able to use this for like single node OpenShift?
So single node OpenShift is a very specific use case, and no, it's not gonna get you in trouble, Andrew. But first off, we want single node OpenShift many times because we don't even have space in the data center for more nodes. Customers are saying, look, I cannot even install OpenShift in a cluster of 3 nodes, right? Which we support as well with IPI, what many people call a compact cluster. So you need a provisioner node to deploy OpenShift with IPI, right? The node that Rhys was showing us and described for us. If you have SNO and you need a node to provision SNO, single node OpenShift, you're kind of defeating the purpose, right? That doesn't mean that we're not looking into it, because we are actively looking into that. The bootstrap machine that bootstraps the entire cluster with IPI, this is something that we want to get rid of, right? We want to do, an installation that doesn't depend on a provisioner node. Even though, having said that, with the current IPI workflow, you can reuse this provisioner node as a worker. So say that you have 5 nodes, you're not gonna be using a 4 nodes cluster just because you need the provisioning nodes. And so that's there. But with single node OpenShift, it's a very specific use case that we need to look into very, specifically to solve the problems that the customers are telling us they want to solve with it.
Okay. Well, Rhys, I bought you enough time that the node made it into the ready status.
Yep. The machine came up and we have now dynamically scaled our cluster and we have additional capabilities.
And I think the last thing, because we're just a couple of minutes over time here, so the last thing I wanted to highlight is like you can use Redfish or the other mechanisms. It doesn't have to be IPMI with this private network for Pixie and all of that, and it'll just use. I think in that case it'll attach an ISO directly to the node using the Redfish API, and it'll boot that way. So even if your network is less sophisticated, your network team won't give you a dedicated VLAN or something for this provisioning network. You can still absolutely, take advantage of all that. So, sorry, was there anything to?
No, I wanted to say that this is important, the point that you just made, because this is what we call Redfish using virtual media. With virtual media, we are mapping that ISO remotely through the VMC and through Redfish. And as you said, we don't need to ask for VLANs for provisioning or even a network for provisioning, nothing. All we need is access to the nodes from wherever we are doing the provisioning. And that can be, multiple hubs, L3, as opposed to having to be L2 adjacency with Pixie. So that can be important for many scenarios. And then the other reason to use Redfish is that it's, as I was saying before, what we see as the standardized management, API specification and implementations by, I would say, all vendors that to manage hardware in a more consistent way.
Standards are always great, although I always think of the XKCD about there's 14 standards, but it doesn't meet what we need, and soon there's
Create a new
15
one.
standards. Yeah. So we're a few minutes over. I want to be respectful of everybody's time. Thank you very much, Reese, Ben, and Ramon, for joining today. It's been an absolute pleasure having you all on. I know I've learned several things. To our audience, thank you so much for joining today. Really appreciate the conversation, the questions. If you have anything that you weren't able to get out here during the stream, if there's anything else that you would like to ask, please don't hesitate to reach out to me. You can contact me on social media at PracticalAndrew on Twitter, just like you've seen me chatting across the various platforms. Or you can always reach out to me via email, andrew.sullivan@redhat.com. I won't have you all toss out your contact information necessarily. But I'm more than happy. The worst thing that happens, I've heard from a number of you, the worst thing that happens is, well, I don't know the answer, but let's track down the right people who do, and we'll get those answers. So don't ever hesitate to reach out. With that being said, please tune in tomorrow. Just a reminder, tomorrow we will have the What's New in OpenShift 4.9 live stream happening. That is at, I want to say 10 a.m. Let me bring up my calendar real quick here. If I can type and talk. I don't know. I know all of you all Red Hatters, Steve. Steve has this really crazy talent where he can, I've seen him present holding a microphone in one hand, typing with the other hand, and talking completely separately before. And it just blows my mind. Like, I can't type and talk at the same time because my fingers say what my mouth is, or vice versa. So yes, tomorrow at 10 a.m. Eastern time, apologies for not converting time zones, is the What's New in OpenShift 4.9 session. Next week, we will not have a stream here. Please do be sure to tune in to all of the KubeCon stuff that's going on, and I will go ahead and repaste that link in the chat here. And last but not least, I hope everybody has a great rest of their week, and please stay safe out there.
Thanks, folks.
Thanks, everyone.